Hello everyone, welcome back to my YouTube channel. My name is Lata. I'm currently studying my third semester BE in Sri Venkateshwara College of Engineering in the Department of CSE Data Science. Today I'm here come back with a new topic, that is data structure. I'm here to explain some information in data structures. Let us see firstly what is introduction about data structure. In computer science, data structures are a way of organizing and storing data to make it efficient to access and modify. They are an essential component of any software system, and understanding them is crucial for efficient algorithm design and implementation. Let us see what is stack. What is push and pop in stack? A stack is a linear data structure in which the insertion of a new element and removal of an existing element takes place at the same end, represented as the top of the stack. And let us move on to the what is its functionalities. A stack follows the last in first out principle, where the last element added is the first one to be removed. And its implementation is often implemented using arrays or linked lists, and it's commonly used in algorithms related to recursion, backtracking, and expression evaluation. Let us move on to the what is last in first out. This strategy states that the elements that is inserted last will come out first. Basic operations on stack. In order to make manipulation in stack, there are certain operations provided to us. First, push. It is used to insert an element into the stack. Pop. And it is used to remove an element from the stack. Top. And it is also used to returns the top element of the stack is empty, and it returns true if a stack is empty, else it returns false. Size. Returns the size of the stack. These are the following are the basic operations served by the stacks. Push adds an element to the top of the stack. If the stack is full, then it is said to be an overflow condition. And this is the algorithm for push. Begin if stack is full, return and if else, increment top, stack of top, assign value, end else, end procedure. And secondly, pop removes an item from the stack. The items are popped in the reversed order in which they are pushed. If the stack is empty, then it is said to be an underflow condition. Let us see what is its algorithm for pop. First, begin. If stack is empty, it returns end if else, store the value of the stack or of top, decrement top, return value, and else, end procedure. And this is the simple program based on pop algorithm of pop and push. After compiling the program in the compiler, we will get the output like this. Let us see what is queue. A queue is a linear data structure that is open at both ends, and the operations are performed in first out order. We define a queue to be a list in which all additions to the list are made at one end, and all deletions from the list are made at the other end. The element which is first pushed into the order, the delete operation is first performed on that. And this is the example of queue and how it works. And let us see what is characteristics of queue. First, queue can handle in multiple data and we can access both ends. And lastly, they are fast and flexible. And what is insertion? What is insert and delete in queue? And it first, when we look into its operation, a queue follows the first in first out principle, and it supports operations such as enqueue or dequeue. It is nothing but insert and delete method. And when we application commonly used in scenarios where data is accessed in the order it was added, such as printer spooling and network packet handling. Array representation of queue. This is a simple program on based on queues. First we will create an empty queue and a struct to the represent the queue. Struct queue open interval int front rear size semicolon unsigned capacity semicolon int into array uh, closed interval semicolon and struct queue into create queue of unsigned capacity open interval struct q into q is equals to of struct q into of malloc of size of struct q, and this is the arrow operator. Q capacity is equals to capacity, q front is equals to q size is equals to 0, q rear is equals to capacity minus 1 semicolon, q array is equals to of into malloc of q capacity into size of int return q closed interval. And let us move on to the linked list and what is insert and delete in linked list. First, flexibility. It allows for efficient insertion and deletion of elements unlike arrays that requires shifting elements. Implementation. Implemented using nodes that contains data and a reference the next node. Usage. Widely used in scenarios where the size of the data structure is not predefined or a dynamic collection of an elements is required. And implementation of structures and union. Structure. It represents a collection of different elements. Union. It allows storage of different data types in the same memory location. Exploring algorithm. First, it define the problem. First, clearly define the problem that needs to be solved. Second, design the algorithm. Next, design the algorithm to solve the problem considering time and space complexities. Third, analyze and implement. Analyze the efficiency of the algorithm and implement it, making necessary improvements. Advanced data structures. First, trees. Tree data structures are used to represent hierarchically relationships between elements. Second, graphs. Graphs involve nodes and edges and are used to model connections between various data and various data points. Third, heaps. Heaps are specialized tree-based data structures that satisfy the heap properties. And thank you for watching.